Hi, today we're going to learn about prime factors of numbers. Firstly, we should know what prime means. A prime number is a number that has exactly two factors, 1 and itself. Let's see some examples. 3 has two factors, 1 and 3. So 3 is a prime number. 15 has four factors, 1, 3, 5, and 15. So 15 is not a prime number. Here are some tips for you. 1 is not a prime number, as it only has one factor, 1. 2 is a prime number as it has two factors, 1 and 2. 2 is the minimum prime number, and it's the only even one. Unfortunately, there does not seem to be any patterns to help us find all the prime numbers, but we should have a rough idea of the prime numbers between 1 to 100. Any positive integer can be written as a product of its prime factors. That means we can break up any number into a multiplication of prime numbers. Factor trees can help we do it more easily. Don't forget that we're not asking for the factors, but the prime factors. 1 is not a prime number, so it will never be in your factor tree. Let's start with an example. Example 1. Express 72 as a product of its prime factors. Firstly, call the times table and break this number up however you like. 72 equals 8 times 9 or 6 times 12. I choose the first and write the numbers like this. Then continue breaking up each number into a multiplication. 8 equals 2 times 4. When we reach a prime number, put a ring around it. Then 4 equals 2 times 2. Draw the rings. 9 equals 3 times 3. 3 is a prime number, so we also circle them. Now each number on the end of the factor tree are marked with a ring. The factorization is complete. At last, we should check the answer by multiplying all numbers together. 72 equals 2 times 2 times 2 times 3 times 3. Hence, we get the final answer. Now, let's try some harder ones. Example 2. Express 256 as a product of its prime factors. At this time, we may not be able to quickly recall that 256 is the product of which numbers. But don't worry, we can easily find that 256 is even. So let's remove 2 first. Remember to circle the prime number 2. 128 is also even. We can remove 2 again. Circle it. This time, we can blurt out that 64 equals 8 times 8. Now, we can easily break 8 up, like what we do in the previous example. And we should circle each 2. Hence, we get the final answer. 256 is the product of 8, 2. In fact, we found that 256 is 2 to the 8th power. Example 3. 1020. This is a large number. We can also start with removing 2, but it may take a long time to complete the whole factorization. Have you found it? Its last digit is 0. That means it's a multiple of 5. 5 is obviously a prime number, so we start with 5 this time. 1020 is equal to 5 times 204. And don't forget the ring. Then we can remove 2 step by step, because these factors are even. 51 looks like a prime number, but wait, we need to think again about whether it can be factored. Actually, 51 is equal to 3 times 17, and luckily, we get 2 prime numbers here. That means the factorization is done. Now, we get the final answer. Here I'm going to introduce an essential tool that helps us check the solution of prime factorization. CameraMath. It has powerful premium functions. We just need to scan and crop the question, and we can get the answer in a snap. Click on the Show Steps tab. It provides detailed process of this question. More results from the web can also be viewed. Click the link in the description to easily get this app. It's both available for Android and iOS.